The traveling salesman problem, or TSP, is one of the most revolutionary problems in mankind history. So what does it do? The TSP aims to find the shortest route starting from a point and going through a list of points, then returning to the original point. Simple, right? You probably found the shortest route by taking a simple look. But what if the route had more points? What if it had 10, 50, or even thousands of points? Would it still be that easy? So, why is it so important? We can use the TSP in many applications, such as connecting power transmitting networks, PCB drilling, building railroad tracks and subway tunnels, transportation, like school buses. In all these applications, finding the shortest route will result in reducing cost and time. But wait, is the fastest route the same as the shortest route? Well, for many applications the answer is no. And the reason is that there could be many factors affecting the route, such as traffic and transportation. And that's what we did. We simply took these factors into consideration. The resulting routes are totally different, almost in all cases. We did that by creating a virtual distance between every 2 points. This virtual distance will take the factors affecting the original distance into consideration. And of course, just as traffic changes with time, the virtual distance between the 2 points also changes. For example, the Cairo University Bridge is 450 meters. So with a speed of 50 km per hour, you'll need 33 seconds to go across it. Of course, this case never happens because of the heavy traffic. But if we say that the bridge's virtual distance is 2.5 kilometers, so with a speed of 50 km per hour, we will need 3 minutes to go across it, which is a more real case. And as we said before, the virtual distance will change with time, so at 4 AM the virtual distance will be 450 meters, which means no traffic. So only 33 seconds needed to go across.
So, what does the virtual distance do? Well, the virtual distance represents how the cost of the route varies with time. The cost can be expressed in the form of time-varying factors. In our algorithm, the virtual distance is represented by the dot product of two matrices. The distances matrix, which contains the original distances between every two nodes, and the factors matrix, which contains all time-varying cost functions between every two nodes. This kind of TSP is called the dynamic TSP. The dynamic TSP could be used in aerial applications. Wait a second. You could think that in aerial applications there is no traffic. And that is correct. But the factor affecting the cost in this situation is the wind resistance. And of course, it may change with time. So, using a dynamic TSP approach in this problem is far more suitable than the ordinary TSP.